In today's video, we will be talking about the chapter on combination. So I will be referring to certain concepts that I have used in my video on permutation. So if you want to have a revision of that video, you are welcome. The first thing that we discuss are a combination of n things taken r at a time. So here we will be using the joint concepts of permutation and combination, and we'll figure out how to express the expression for combination in terms of permutation. So we'll basically use the expression for NPR in my expression for NCR. So let's denote the combination of n things taken r at a time as NCR and denote the permutation of n things taken r at a time as NPR. We already know the definition of NPR and the underlying concepts below it. So when we are talking about permutation, we essentially consider all the orderings and the arrangements. On the other hand, when we talk about combination, we ignore the arrangements and we merely consider the selection of R things that we are choosing from the n original items. So if I talk about permutation, simple permutation, then I get the expression NPR on my right hand side. But if I go to the definition of combination and try to derive the concept of permutation from combination, what I have is I have combination of n things taken r at a time. This part does not take into consideration the ordering of the r things. So we essentially have selected the r things from the n original things. What we do in the next step is we rearrange those r things in r factorial ways. I have discussed in my previous video that when we have permutation of r things taken r at a time, we are essentially rearranging those r things among themselves. So this is basically permutation in the language of combination. Now we are essentially expressing the two halves of this equation which represent the same thing. They are both permutation. So if I express NCR into r factorial equal to NPR, then NCR would naturally be NPR by r factorial. What I've done is I've basically divided both sides of the equation by r factorial. Now, as you know, NPR is basically n factorial by n minus r factorial. The r factorial remains in the denominator over here, and what we essentially have is the expression for NCR. So we have NCR is n factorial by r factorial into n minus r factorial. So you see the term on the superscript left hand side of the letter C is still there in the numerator. The term on the subscript right hand side of the letter C is there in the denominator, and the difference between the term in the numerator and the denominator also exists in the denominator in product form. The next thing that we'll move to is kind of like a corollary. So what we have from the previous form of expression is NCR equal to n factorial by r factorial into n minus r factorial. Now what happens if I replace this r with n minus r? Naturally, we'll replace this n, we are replacing r with n minus r. So in this expression, we will replace r with n minus r over here and this r with n minus r. So NC n minus r will be n factorial by n minus r factorial into n minus r factorial. If we break this bracket, then we'll naturally have n factorial by r factorial, because if we break this, we have n minus n plus r factorial. I take that r factorial before this term and I have r factorial, and I write this n minus r factorial in the later half, and I essentially find out that NCR, expression for NCR and the expression for NC n minus r is essentially the same. So here we reach a conclusion that NCR equals NC n minus r. That is a very important expression in the chapter of combination. The next expression we'll come to is we'll try to find out the value of NCR plus NCR minus 1. First, I will talk about the mathematical derivation and then I will express the intuition behind it. So if I just mathematically break the expressions, then NCR is n factorial by r factorial into n minus r factorial. And NCR minus 1, instead of r, I write r minus 1 factorial. So I'll have n factorial by, instead of r, I write in r minus 1 factorial, and instead of r in this place, I write n minus r bracket. So I break it at the same step and I get n minus r plus 1 factorial. Next step, I take n factorial in the numerator common, and I write the rest of the expression as 1 by r factorial into n minus r factorial. And from this expression, I get 1 by r minus 1 factorial into n minus r plus 1 factorial. In the same step, I make some adjustments. What I do is I multiply n minus r plus 1 by n minus r plus 1 to the fraction. So I multiply the same term to the numerator and the denominator for this fraction. And for this fraction, I multiply r on both numerator and denominator, which essentially keeps the fraction values as same. So the next step, if you see, n minus r factorial into n minus r plus 1 essentially will become n minus r plus 1 factorial, because when you multiply, let's say you have 1 into 2 into 3, so that's basically 3 factorial. When you multiply a factorial term with its next term, so let's say you multiply 3 factorial into 4, you essentially multiply 1 into 2 into 3 into 4. So that naturally becomes 4 factorial. So when you multiply a factorial term with its next term, then you essentially have the factorial of the next term. So if I multiply n minus r into its next term, n minus r plus 1, I'll have n minus r plus 1 factorial. And I keep the numerator as n minus r plus 1, no adjustments there. Next, what I do on this side is I multiply r and r minus 1 factorial. Going by the same procedure, I'll have r minus 1 factorial into r, where r is the next term of r minus 1. I get r factorial. So I have r by r factorial into n minus r plus 1. Now what, oh, I didn't close the bracket here. Now what I do is, if you see, this denominator for both the fractions are same. So we can add these two terms because they have the same denominator. So what we have is, we have n factorial by, the denominator remains the same, and on the numerator we have n minus r plus 1 plus r. So these two r terms get cancelled and we are left with n plus 1. So we have n factorial into n plus 1 by r factorial into n minus r plus 1 factorial. Again, going by the same procedure, you see n plus 1 is the term after n. So they are terms one after the other. So naturally we'll have n plus 1 factorial. And finally, we come to the conclusion that the expression for NCR plus NCR minus 1 gives the expression n plus 1 factorial by r factorial into n minus r plus 1 factorial, which is essentially n plus 1 CR.